thank you all very much for staying, and appreciate you coming to the session. So this is a little bit of a kind of a vision talk meets product talk. Basically, 4.5 years ago, I started a company with a vision, and 4.5 years later, we've built a lot of that vision out. We're not done, but what this talk is really about is a little bit of that journey. So a little bit about my history and how I started in Hadoop, some of the challenges that I saw and experienced, some of the challenges we've seen with our enterprise customers, and basically an approach of how to solve a lot of these challenges that are inherent in Hadoop and big data, both from the complexity of the technology standpoint as well as the diversity of users who are trying to somehow be involved in that big data lifecycle. Developers, operators, line of business execs, data scientists, business analysts, all these different constituents ultimately play into success in big data for enterprises. So we'll talk about all of that, and then I'll show you what our product is, which is an attempt to kind of address these challenges. And my goal, for those of you that just joined, I want to do a demo of some new stuff I've just been working on. And so I'm going to try to get through the content fairly quick so we can actually look at the product, look at how it actually feels and what kind of stuff you can do, because I think the use case will help drive home the point of what this platform can do. Before I start, we call this thing the DAP. Our platform is called CDAP, the Cask DAP. And DAP stands for Data Application Platform. If you don't know, DAP is also kind of a slang term for a fist bump. So if you see fists and things like that, that's because it's a little play on that. So one quick slide about my background, just for some context. So my background started as more of a relational database developer and building on app servers and .NET and PHP and the traditional kind of 3-tier web applications. And I had a company, a startup called Streamy, that was basically a social RSS newsreader. And we built crawling engines, we built recommendation engines, we did NLP. And the first version was built on Postgres. And the second version, we migrated to HBase. And I spoke about it at Hadoop Summit, I think 2009. The whole story of how we migrated from Postgres to HBase in 2008, 2009. And so basically, I got really into HBase and became one of the main committers of HBase. Because it turns out in 2008, 2009, HBase wasn't really quite a database yet. It was very, very early in that project. But the promise was there. And Google had already kind of validated this big table model and put some really big apps in production on it. And so I got really into the real development of HBase itself. And that landed me at Facebook, where I was kind of like the HBase guy for a couple years. And we launched Facebook Messenger. So Messenger, every single smiley you put in Facebook Messenger is stored in Hadoop and HBase and served out of Hadoop and HBase. There's tens of petabytes today. We built a whole bunch of kind of real-time analytical applications like Facebook Insights. It's like Google Analytics for Facebook. All that's powered by HBase and Hadoop. But the amount of work it took to deliver those applications and people with deep, deep expertise into the system side and the actual HBase implementation and things like that, that's kind of what the team was. It wasn't an app dev team. And coming out of Facebook and into enterprises and smaller companies and things, you really need a different way to do development. You can't put 10 rockstar engineers and give them 12 months. That's just not the possibility. And so the idea was, when I left Facebook, to start this company, basically to help other types of developers, other types of enterprises, other types of companies deliver the same types of solutions that the internet companies are, but in a much faster, easier, simpler, higher level way. And that's really the vision of the company. And the rest of this will explain that. So when we look at Hadoop, we really think about how much it's enabling these brand new applications and these brand new patterns, right? You kind of had the data warehousing and things like that of yesteryear, and now you have this new notion of the enterprise data lake. And companies are dealing with ingestion, ETL, SQL exploration, data science, data as a service, things like that. And then as companies and users adopt Hadoop more heavily, you kind of get into this new analytics. I think of like BI 2.0, building the customer 360, doing real-time dashboards, breaking down the silos and bringing in new types of data sets. So now I'm bringing in my time series data, I'm bringing in my web logs, not just looking at my data warehouse and my structured data. And ultimately, closing the loop and actually turning these insights into action. And a lot of where we see the future and some of the most disruptive use cases in Hadoop and big data is closing that loop. Not just generating a report, not just doing BI, but actually triggering an upsell recommendation to your user when they're on your mobile app, when they're on your website. Doing a real-time anomaly detection on your network and triggering some kind of remediation action. Doing IoT type of use cases, near real-time event monitoring, things like that. As you go down these use cases, as you progress, the value increases, but so does complexity. And doing batch data ingestion and an ETL job is one thing, but a user-facing real-time ingestion, real-time serving application on the same stack is a much different thing to deliver. And the DAP is really about the fact that this is a kind of a continuum. And it can be one developer actually responsible for this entire thing. There's no longer an ETL team who delivers that developer a polished, golden, perfect data set to put the app on. That developer is responsible for, hey, the data's sitting over here. Load it in, do some ETL on it, then write your apps on top of it. It's the same team and the same individuals often are responsible for that whole thing. The other constraint here in Hadoop is there's a lot of different types of users who ultimately have a say in delivering that recommendation engine, as an example. I have developers who are doing Java programming, things like that, very focused on building application and business logic. I have data scientists who are the ones who are building the models, determining what features to do, determining how to enrich the data properly. You have the ops team, the IT teams who are focused on actually deploying it, actually managing, monitoring, configuring it, keeping it up. Very different team oftentimes from the people actually responsible for building it. And then this really big gap exists to the business, to the line of business executive, to the product team, to the business analysts who speak the vertical domain, who really speak the language of the business, but they don't speak the horizontal kind of language of Hadoop itself. And the challenge is that there's not really tools here. There's not really a platform or tools that connect these users and help take your app from prototype into production, with each of these people kind of doing their part along the way. Off the back of that, there's just inherent challenges with Hadoop based on what Hadoop is. So Hadoop today is over 50 projects, right? So this is a fast evolving ecosystem that is continuing to innovate on the bottom level. And so it's inherently complex. There's a proliferation of products, services, and APIs. Ultimately, that's a really good thing. What's great is open source innovation is allowing tons of new stuff to thrive, but that creates a lot of challenges for enterprises, developers, and operators. There's also very little reusability. If I build a solution that pulls from Kafka and writes into HDFS, and there's a Spark job on top of that thing that writes into an HBase table and some web service on top of that, I've kind of probably created this kind of behemoth thing where the app and the integration is the same thing, right? I didn't really build out a little reusable library, or my connection between my Spark streaming job and Kafka wasn't really generalized. It was built one time for that application. And portability, which is something that we've looked at a long time, but only really very recently has become very important. You're seeing divergence of distributions now. You're seeing the different Hadoop distributions, the different clouds now kind of purposefully creating different projects to solve similar technical challenges. And then again, you're seeing this proliferation of technologies with different distros supporting different technologies, clouds supporting different versions of that. And so it's a very complicated ecosystem. Now to look a little bit at analogy, right? This is a traditional application architecture, right? You have your hardware. This was typically a scale-up type of hardware. You'd have your operating system. You have some set of native applications written directly on the OS. But more than likely, things are being built on top of some kind of application framework. That could be JBoss, Tomcat, WebLogic. It could be PHP. It could be .NET. Those things are actually really application frameworks. They're not really apps directly written against the operating system. They embed all kinds of libraries and capabilities inside of them. But that doesn't really exist today. Today, when you're building in Hadoop, right, we have the same analogies. We've gone from the kind of scale-up hardware to the scale-out commodity hardware. We've gone from single-node operating systems to these distributed operating systems like Hadoop and Yarn. But today, you're still building your app directly on top of it. And the DAP is really about introducing the application and integration framework here that provides abstractions, integrations, reusable building blocks, lifecycle management, all those types of things. if you look at the other side of this, not the development of it, but actually what it takes to deploy and operate a data application, it starts down here with the individual components and libraries, moves up through all the unit testing, integration testing, performance testing you have to do, and then gets into production, where you have to deal with security and governance. You'd have to do monitoring metrics and logs, packaging, versioning, deployment, all of these different kind of production concerns. Well, you still need those in a distributed application environment, but if you look at what you are getting from a Hadoop distribution or cloud today, you're really lacking in a lot of these different areas. And it's not that there isn't anything. It's not that there isn't any security and governance. It's not that there isn't any testing. It's that these things are pretty much point solutions, and they're also focused on very specific individual components in the ecosystem. And so while there are an increasing number of integration solutions, and clouds and Hadoop distributions are starting to provide more and more of it, you're getting these silos. You're getting a tool for a data integration. You're getting a different kind of system for the application integration, a different system for cloud integration. Governance, security, monitoring, application performance management, these are all being done as these kinds of different point solutions. And so again, you're kind of stuck now gluing together multiple different systems. That's really what the DAP is about. The DAP is about bringing these things together. It's about recognizing that big data is about this convergence of data and applications, and that oftentimes the same development team is responsible for taking things from prototype to production, and also realizing that there are many roles involved with this process. And so the DAP is built on top of Hadoop. So it does not replace Hadoop. It doesn't replace what's in the infrastructure. Think of this more as like middleware, an integration layer on top of it. It starts with providing flexible deployment. So you should be agnostic to the Hadoop distribution. You should be agnostic to being on-prem, cloud, any of those types of things. You should have user experiences targeted at the different users of that platform. And then you need a whole bunch of different kind of integrated capabilities, right? So starting with the integration, orchestration, workflows, prepackaged integrations and libraries, operations and governance. So Cask, we started this company about 4.5 years ago. Like I mentioned, I came out of Facebook. My co-founder was an early Hadoop engineer at Yahoo. And so we're based down the street in Palo Alto and partner with all the Hadoop distributions. We partner with all the cloud providers. And we work with large enterprise companies like these guys to help them move way faster when it comes to their innovations around big data. And a cool thing, we were named a cool vendor by Gartner this year. So CDAP. CDAP is 100% open source, and it is an integrated framework for building and running data applications using technologies like Hadoop and Spark. So we support all the major Hadoop distributions, complete portability of all your apps. We integrate with all the latest and greatest, things like Kafka, Spark, Yarn, HBase, Hive, Hive on Spark, Hive on Tez, all of the good stuff. The next release will be integrating with Flink. So we really try and stay on top of what's the latest and greatest. Again, 100% open source and built for extensibility. This is intended to be adopted and turned into your own platform. And so everything is extensible, changeable, and flexible. And again, we're essentially this layer on top of all of the different underlying ecosystem components. On top of this platform, so far you can think of this very much as a kind of Java developer and operators platform. We've built things that help touch the other users who are not as comfortable programming. So Hydrator and Tracker are self-service user interfaces. Hydrator and Tracker are self-service user interfaces basically for doing data ingestion and data pipelines without writing code, and then doing the data discovery, metadata audit, and lineage of all of those data pipelines that are being created. So if a data scientist wants to take some data that's sitting in S3 or sitting in a Teradata instance or something, load it into HDFS and run some Hive queries or plug it into R, they can stay in this UI. They can never have to write a single line of code and do all of it in a very self-service way while maintaining the kind of control that the IT and ops teams need. So CDAP, we really think about kind of 3 major areas of value as you go through the whole life cycle of applications. It starts with enabling rapid development. Generally, we see about an 80% reduction in time to develop and deliver applications. Helping with production operations. Oftentimes in projects, we see 20% is doing the actual development, and it takes 80% of time to put that development into production. We want to reduce that way, way down. And then enable enterprise governance, right? And as much as possible, that should come for free as part of the framework. So it's one framework, prototype to production, on-prem to cloud. Everything is flexible in both things. And it provides a unified approach across the different projects and paradigms. So you might be working with Spark or MapReduce. You might be working with HDFS or HBase. But you don't necessarily want different audit and lineage systems or different governance, different security. The same for monitoring metrics and logs. Do I want to ingest logs or metrics into my dashboarding systems in a different way for each system? Or do I want a single consistent API that I can just integrate everything with? The way we do that, we call it a kind of container architecture. So think about this similar in approach and value as Docker, but up the stack in the application and data space. And so whether you're doing Spark or MapReduce or a workflow or a web service, we call that a program. And whether you have HBase tables or Avro files or Parquet or whatever it is, we call those data sets. And so as all of these things interact, you capture audit and lineage of programs and data sets interacting. All of these can be versioned and packaged, deployed, managed. The way you get logs and metrics, the way you store metadata, retrieve your metadata. It's against the notions of data sets, programs, and applications. So the way you integrate this system into your existing infrastructure, into all your tools and ops systems, is against these three standards. And then we create integrations into all of the underlying systems, right? So today we support, for example, MapReduce and Spark as very, very core important things. We'll be adding Flink soon. What happens is the developer now gets to use Flink, right? All of their data sets will already integrate with Flink because programs and data sets can always speak to each other. And then the ops teams, the security teams, and the governance teams don't have to worry about what does it mean if this person writes a job in MapReduce, Spark, or Flink. It's all the same once you're at that level. We also really simplify the deployment architecture. Systems like Yarn are massively distributed systems. So if I want to create, for example, a REST service on top of an HBase table, well, I might start that REST service somewhere in Yarn, but now I have to do service discovery and routing. And if I want it to be highly available, if I need to scale it, I've got a lot of different work to do. CDAP simplifies everything by giving you a router that sits on the edge node and provides a REST API for everything you can do in the platform. Data ingestion, lifecycle, deployment, management, anything can be done through REST, including hitting your own web services and all that stuff. And so it makes it very easy to create HA applications, very easy to deploy lightweight services, things like that. This also integrates with security systems. That's the auth server. So if you're using LDAP, you're using Active Directory, or you're using Sentry and Ranger and things like that, the auth server integrates with all of that. What happens is we publish all of the program's data sets and application entities into those tools, and you can use them to manage fine-grained access control, and that pushes it back down into CDAP. So this is a kind of a complex diagram, but it's really showing how in a end-to-end Hadoop kind of architecture, starting from data sources, doing data pipelines, ingestion into your data lake, enabling ad hoc exploration, ad hoc queries, doing more of your production ETL, scheduled workflows, production applications, using that to deliver insights and serve them up to different applications and business processes. So you're starting with developers, you're ending with line of business, and you're enabling access to the scientists and analysts that need access to the data, and you're providing a much more cohesive, conceptual framework for the operations and governance teams. All right, demo. Perfectly halftime. All right. So I mentioned this notion of portability across distributions and everything like that. One of the other things that we're portable against is there's 3 different runtime modes of CDAP. So when you build in the CDAP framework, there's obviously the distributed mode that runs in different Hadoop distributions, all that stuff. It can be installed with Cloud Air Manager or Embari or anything like that. But there's also 2 other modes. So there's one called standalone, and that's what I'm demoing here. So this is a single process version of CDAP. It runs on your laptop, and it uses the local file system. It emulates HBase. It emulates Yarn. It starts a little local Hive in it, a little local Zookeeper, a little local Kafka. But basically provides a single node version that's fully functional. So you get the UIs, you get all the tools, everything works exactly the same, but it's on your local machine. So much, much faster to do development, the types of things you do for demos and things like that. And then there's an in-memory mode. So you can take your exact same application and test it in memory. It doesn't start up all of the different infrastructure systems. It mocks a lot of them, so it starts up in like about a second. Whereas if you use mini HDFS clusters and mini HBase clusters and mini Zookeeper servers and all that stuff, it can take like 20 seconds just for the unit test to start. This is way, way more lightweight, so it's easier to set breakpoints, easier to debug. So as you can see, I basically wiped all the data and logs and restarted it. And if I go over here, this is the CDAP home. And you can see I don't have any data, I don't have any applications, I've got nothing there. And this is the menu that you can jump into Hydrator and Tracker, which are these higher level tools. So let's see here. How do I want to go about this demo, the first time I've ever done it? So I want to start with some code. So we talked about this notion of, where's my table? So one of the things that CDAP allows you to do, and is a really important aspect of it, is encapsulation and basically exposing libraries, right? So if you think about HBase as an example, HBase's API is fairly low level, and you have to kind of know how it works in order to implement data models on it. If I want to do time series, or I want to build like an OLAP cube, or I want to do indexes, or a geo-index, HBase is really well suited for a lot of those patterns. You kind of have to understand how HBase works to make sure it scales, to make sure you're not getting hotspots, to structure the reads the right way, all that kind of stuff. And so what the dataset framework allows you to do, besides giving you kind of standardized packaging and management, is also create libraries around those datasets, right? So in this case, this demo is all about a new dataset that I've been working on called the Cask 360 table. So this is an abstraction on top of HBase. And what it does is it gives a wide row model. So basically, one of the reasons HBase gets used for 360 use cases a lot is I can have one row that's my customer, and I can put 1 million columns inside of that row, right? And all the columns of that row don't have to relate to any other row. And so basically, I can keep adding and enriching what I know about my customer and keep all of that data for each customer completely together. So HBase is great at doing that data model, but it doesn't provide it out of the box. What I've done is created this Cask 360 table. And so then what it allows me to do is encapsulate all kinds of things about this data model I want and expose it at a higher level. So look at these interfaces that it extends. So the first is it's a data set. We know it's a data set. The second is record scannable. Anything that implements record scannable can have a SQL query run against it. So when I implement record scannable and I implement a couple of interfaces, now when I create a Cask 360 table, it's automatically going to be added to hcatalog, and I'll automatically be able to run a Hive query against it based on the implementation of the record scannable, right? So I can just go and create an instance of this thing in the system, and it's already existed in Hive. This thing defines how it works in Hive, what the SERDI is, what the schema is supposed to be. Batch writable and batch readable, kind of self-explanatory. It makes it so you can read from this thing in a batch job, and you can write to this thing in a batch job. So once you have batch writable and batch readable, what it means is any CDAP program type supports batch readable and batch writable. Any batch program type supports batch readable and batch writable. So by doing these interfaces, I can read and write from Spark. I can read and write from MapReduce. And then I actually have my synchronous APIs. So basically, it's a very, very simple API. You write this Cask 360 entity object that I have, and you read an ID, and you get the object back. So it's a very, very high-level API that puts everything into this Cask 360 type. And then there's an actual implementation of it. And lots of good Java doc. So here's the class that implements Cask 360 table. Underlying it is 2 tables. These are HBase tables, right? So basically, what the object does is it encapsulates 2 underlying HBase tables and surfaces this Cask 360 API to you. To construct it, you pass in the underlying tables. And basically here, what you're going to see is business logic, basically, about how you write these Cask 360 objects into the tables. And you'll see actual put operations here. You'll see the actual stuff happening, right? Now I want to test that table. I write test Cask 360 table, extends test base. So by doing test space, when you extend that, when this unit test starts, the in-memory version of CDAP is started with it. And so what I do here is I have a very simple app. And all I do in the app is create an instance of this Cask 360 table. And then in my test, all of these hooks are basically part of test space, right? So I deploy application, give it the application class. That deploys the application. So it would deploy any Spark jobs, MapReduce jobs, workflows, HBase tables would get created. All that happens. I now get a reference to the data set from the dataset manager, and I start issuing reads, issuing writes, all that kind of stuff. And basically, the framework provides ways for you to do assertions and all that type of stuff. So you can put data in here and wait for it to come out the other side, validate it's correct. Now let's actually put this thing to use. Oh, one other thing. So I can also then take this. This is really programmatic, right? Allowing me to write my Java apps and stuff on this higher level API. But let's say I also wanted to expose this thing as a web service. I wanted to read and write from that data model through REST API. So I can build this thing called the Cask 360 service. You hand it the name, description, and table. So it's very interesting. This runs in some Yarn container somewhere, right? But it's dynamic. So I actually hand it the table name I want it to reference as a parameter. But this is a distributed system. This spawns somewhere else. So I actually have to get the data there, the configuration to it somehow. But a lot of what CDAP does is introduce things like annotation. So when I have a class and I put property on it, it automatically gets serialized and unserialized on the other side. So there's a lot of tricks that you do here. So I can just kind of create Cask 360 service and put the dynamic things in there. This will spawn up on another node, and that will get pre-populated at runtime. And this looks a lot like writing a JSP or a JAX-RS style web service. So it's my service handler. I'm dynamically handing in the table name. And here is my reference to that table. And here's where I'm setting it. And then I'm just implementing read and write things, right? And inside, table.read. Very, very, very simple. And this supports JSON response, so I just have to give it another Java object, and it'll turn it into a JSON and send it back as a response. One last bit of code, and then we'll actually do some demoing. So this is what an app looks like. So we kind of look through a data set, things like that. Now, how do you actually package this up into an application? So you basically write this one class with this one method called configure. There's the name, the description. I'm creating a data set that's of type Cask 360 table. I'm adding a service of Cask 360 service, and you can see where the dynamic properties are being set. I'm creating a stream. A stream is a special concept in CDAP for doing ingestion. When you create a stream, I can just start firing events to it. And a flow, which processes events out of a stream and writes into the Cask 360 table. And this is kind of a little demo app I've built around the Cask 360 table. And now I'll go and demo all of this into the platform to show you how it works. So the use case I wanted to do is basically create this Cask 360 table. I want to do a pipeline, a visual pipeline, to load some CSV data I have on my hard drive into that Cask 360 table, and then show you how you can run SQL queries against it. I'll deploy the application and show you how you can hit that web service against it, and kind of everything comes together around that abstraction. So first, let's go into Hydrator. Let's create a pipeline. OK. So I haven't yet actually, there's one thing I didn't do yet. So Hydrator, think of this as like data integration ETL stuff. And syncs are things that you can write to, right? And so it has like table in here. It has some other stuff, external data sets, all kinds of stuff. But what I actually want to do is have a pipeline that writes to the Cask 360 table. So I want a Cask 360 sync, right? And this is one of the other things CDAP allows you to do. I can take that Cask 360 table and not just surface it to my Java devs. I can create what's called a Hydrator plugin and surface it in here. So now you don't even need to write code. I can just create pipelines right into it. So that code looks like this. It's actually not very complicated at all. It's about 20 lines of business logic. And one file of configuration. These are the different configs you need, right? And so you implement these two different classes, and you implement this JSON file. So this JSON file is basically saying what are the configuration parameters for this plugin? What's the table name, basically, things like that. And that allows you to package it up and deploy it, and you see it now show up in the UI. And so I'll show you what that works. So I take this project, I generate a jar file out of it. You build a Maven project, basically. And then you can go over here and add new plugins. So this is under plugins, target, Cask 360 plugins. And then there's a JSON file, as I showed you, that describes how it should look in the user interface. So I'll upload this. Artifact successful. So now when I look at sync, perfect. There's Cask 360. All right. So now let's load up this file. So as I promised, this is the file. So it's just a CSV file of some customer data, right? This is all fake data. Name, address, email address, things like that. So I'm going to pull from the file source, which is the local file system. I'm going to do CSV parsing. For fun, I'll do a JavaScript function, and then I want to write it out to my Cask 360 table. So starting with the file, I'm going to give this a reference name, which is, I'm going to actually track metadata. So CDAP has a notion of managed data sets and external data sets. So HDFS and HBase and those systems are native managed data sets. But a CSV file on your hard drive or a Teradata remote instance, we call an external data set. But we actually track it too, because it becomes part of the lineage. So if you look at the HBase table, you'll be able to see, or this Cask 360 table, you'll be able to see it was derived from the file. And I'll show you how that all comes together in the next 8 minutes. Here, my CSV file. And we give it the path. We'll connect it up to the parser. And right now, I have to do this manually. All right. We can do little inline JavaScript stuff if we want. So input.name equals like input.first plus input.last. And we'll change that to name. And then let's write that to the Cask 360 table. So here we see that schema is already being derived. We'll call it customer 360. The group name, so basically you would name each source to the data. So when you look at your customer, it's grouped by the group name, right? So I might have my CRM data, my weblog data, my third-party Marketo data, and all of those are group names. So we'll call this CSV because it came from CSV. You can either store maps of data or you can store time series. In this case, it's going to be a map. And we're going to use ID as the field. And that's it. Let's call it our customer importer. Let's save it. Now, so far, like, there's no code, there's no nothing. I can actually deploy this and run it right here. But it also is kind of developer and production friendly. So you can take any of these pipelines, and underneath it, it's just a JSON configuration. These JSON configs also support parameterization. So you can put macros inside of it, and at runtime do replacement of the configs. A lot of really cool features around how this works. But you don't even have to look at this if you don't want to. And you can just publish it. One other thing, you can schedule these, and you can also switch the engine. So this pipeline can run either in MapReduce or Spark. I'll do Spark because that's always more fun. Now, hopefully this works. So now this is turned into an application running on CDAP, right? Made of programs and data sets. And now the moment of truth. So part of what Hydrator does is it allows a non-technical user to stay inside of Hydrator. I don't even see Spark here. I don't even know exactly what's happening. But you can hit the little CDAP icon, and it takes you into the CDAP side view, which is the developer and ops side. And this allows you to actually see everything underneath it. So there's a workflow. That workflow contains a Spark job, and there's this customer 360 data set associated with that. Oh, looks like it ran. Very nice. So again, log aggregation. You see all the logs from all the different Spark containers right here. I can see I have this application. I can go and look at its data set now. Click this data set. The schema from my pipelines automatically been associated with the data set. I can see I have about 1 meg of data written into here. Every data set supports SQL. So really interesting thing. I kind of told you how I implemented the thing of how does it return SQL. So if you think about the data model, right, it's this really wide row data model where each user is associated with all kinds of data that doesn't map to SQL, which is a very flat type of thing. But basically what it does is it flattens it. And so what you get is a schema of the ID, the group, the type, the timestamp, the key, and the value. So it basically takes that big three-dimensional nested model and flattens it out. And so you can put this into a Tableau, you can put this into OLAP tools, all different types of things can support because it's a flattened SQL schema. Now, what do I got? 3 minutes. All right, 2 things to show. So one thing I want to show is Tracker, which is not even enabled. Oh, fuck. Oh, OK. I'm not going to show you Tracker. This is actually a development build of the platform, that's why. All right, I'm not going to show you Tracker. Instead, I'm going to show you deploying that application, right? So I haven't actually deployed any application because I did everything through Hydrator and the UI. But if you remember, I built that Cask 360 app. So just like the plugin, I can build that application into a jar file. Wait, yes, right there. Cask 360 core. So that's the thing that contains my application. So I can go add application, and I can add a custom app, which is basically one I just built. So I'll go to there, go to the target, deploy this jar file. It's uploading, and it's deployed. So now this app has been created, this app has been deployed, any underlying data sets have been created, all that's happened. I actually made the app reference a table called Customer 360. So in this case, that data set already existed, so the app didn't have to create it. If it didn't exist, the app would have created it. So now if I look at that app, what I really want to do is use this service. This is that web service. So I'm going to start it up. I hit the start button, and I can see what endpoints does it provide. I can set multiple instances, and there's different policies for load balancing, all that good stuff. But I'll just do a simple query here where I'm doing a get on /entity/1. Right? Get me entity 1. Request successful. And now what you see is the structured three-dimensional view of that data. Right? So if you remember, this was being flattened out in the SQL schema. But when I'm doing REST and I'm doing JSON, I can create really long nested objects. So all of that data is there. You can see it's grouped under CSV. So if I go into another input and I call it something else, that'll be another area of that JSON. So now I can write into that Cask 360 table through these APIs. I can read from them through these APIs. I can run Hive SQL queries against it. I can build Java applications against it. Right? Once that Cask 360 table becomes codified, once it's accurate, you've run tests on it and it works and it implements a data model as you expect, you can now push that into everyone's hands. And no one ever again has to think about how do I model my Cask 360? How do I model these wide rows? How do I actually operate on that data? How is that data integrating into my Tableau or my BI tool? How do I run SQL against it? This all creates this kind of consistency around that. So we got about 1 minute left. That was about it for the demo. So since this is the last session, I'm happy to kind of take questions, and we can riff offline. But basically, building, deploying, and operating modern distributed apps is hard. And in every previous generation of technology and infrastructure that's come out, higher level integration layers, middleware, libraries, abstraction, reuse, this always happens. And Cask has been at this for about 4.5 years to try to solve this for the Hadoop and NoSQL space. Today, we have an integrated framework that makes it very fast for you to do things like data pipelines, app integration. all that good stuff. This is 100% open source, focused on developers and their constituents, like operators, data scientists, and analysts. So I encourage you to download CDAP. Again, 100% open source, so you can get going. The demo I just ran is on the same thing that you would download right now, except you won't have Cask 360 because that's my project that comes out next release. So, and that's one of the things that we do. So not only is it about customers able to build their own patterns, but as we see really common patterns emerge, we build them into the platform, right? So time series, OLAP cubes, geospatial indexes, object stores, some of the more industry-specific things like call detail records or things like that. We have libraries already built out for that. So we've done a bunch of stuff already for common patterns, and then we work with customers to help them develop new ones when they do need expertise. But the power is, it's kind of a build once, and then you get to reuse that over and over and over again. So, time's up. Thank you very much.